Okay, let's look at an example of how to find moles or mass if you're given your moles. So I'm just looking at the guided notes section of our Unit 6 assignment. And one of the questions here, I've actually pulled question E from that. You're given a known mass of substance. So here's the mass in grams of sodium chloride or table salt. Okay? And it's asking us to find the number of moles. And now that I have these kind of sheet triangles, my 3 triangles I've drawn, I just have to take a look and see which triangle is the one that contains grams. I'm given a mass here in grams, so I'm going to take a look at my triangle and see which one is the right one. Okay, this triangle right here has grams listed in it. And the question is asking me how many moles. Right. So I'm going to use that triangle to calculate. And maybe I'll even bring the triangle down here with me so I can see it right next to the question. Okay, I'll just slide this one out of the way. Okay, here we are. Okay, so you can set up your question within the triangle if you want. I'll draw the triangle to find my answer. Okay, so it's given me 11.2 grams. I'm going to write that right here in the spot of my triangle that lists the grams. I don't know how many moles that is. That's what I'm trying to find here. So I'll just write a question mark equals how many moles. I also don't know this part, the molecular mass, and the compound I'm given is salt. I need to find the molecular mass. To find that mass, the molar mass or molecular mass, I need to add up the total number of sodiums and the total number of chlorines, their atomic mass units. So down below here I have a periodic table. Sodium is a metal. It's over here on the left side of the table. It's 22.99. Now when a number is that close, you can safely round it up to 23. So let's do that. I'm going to go back up here and I'll write 23 grams per mole. Sodium. Chlorine is a non-metal. It's over here on the right side of the table. Now chlorine is listed at 35.45. I'm not going to round that one because it's not close to a whole number. 35.45 is pretty much right in the middle between 35 and 36, so grams per mole. Alright, I'm just going to get rid of this arrow out of the way. If I add those two together, I'll get the molecular mass of sodium chloride. So that equals 58.45 grams per mole. And I'm going to write that right here in my triangle. Grams per mole. Okay. And using this triangle, I know that this line here, the horizontal line, represents divided by. So all I need to do in my calculator is put 11.2 divided by 58.45 will give me the number of moles of sodium chloride. So I'm just going to take a calculator here and do that. 11.2 divided by 58.45 equals 0.192. I'll round it to 3 decimals here. 0.192 moles of sodium chloride. And that makes sense. Remember that this number that we calculated up here, the 58.45, that actually means that if I had 1 mole of sodium chloride, it would weigh 58.45 grams. I didn't start with that much. I only have 11.2 grams, which is much less than the 58.45 of a total mole of sodium chloride. So my answer should be less than 1 because the given amount is much less than that 1 mole mass. Okay. Let's try another one here. Let's try one. What if we were given the opposite scenario here. So I'm just going to create myself a little bit more room. I'm going to move some of this stuff out of the way here. I might have to get creative with board here and create some room here in a moment. Let me kind of clean up some of this mess here. So I'm going to take a look at the next question here. Question I. What if the question was backwards and it asked me for to find a mass? So let me just actually erase this other stuff here for the time being. Let's get rid of this and that. There we go. This time it wants me to find a mass, and I'm asking myself, do I know the moles? In this case, yes, it has actually given me the moles of a compound. It looks like diphosphorus pentoxide, okay, P2O5. Okay, but the question is asking for a mass, so it's going to be using this same triangle, the mass or molecular mass in moles. So I'm actually going to answer it the same way. I'm going to draw the same triangle. Okay, it says find the mass of 0.65 moles. Okay, I know how many moles there are, so I'm going to write it in my mole spot. I don't know what the mass is. I don't know how many grams that is. And I haven't calculated yet the molecular mass. That's sort of the missing part here. But I do know that I need to look up phosphorus and oxygen. The molecular compound, phosphorus and oxygen, are both on the right side of the periodic table. There's phosphorus, and it's 30.97. Pretty close to 31. You could probably get away with rounding it. I'll probably just write it as is. And there's oxygen, it's 16. So phosphorus is 30.97 grams per mole. Oxygen is 16. Now I'm going to have to multiply that by 2 because I can see that there are actually 2 phosphorus. And oxygen I have to multiply by 5 because there are 5 of them in the compound. So I'm going to need a calculator to do that. And let's just move this stuff over to the side here, just so that we get rid of that little arrow. Just so we have some room to draw here and calculate. Okay, we got 30.97 times 2. That's 61.94. And we have 16 times 5. 16 times 5 should be 80, yep. Equals 80. I have to add those two numbers together, so 61.94 plus 80. 61.94. And I get a molecular mass of 141.94. That's the molar mass that I was missing there, and the molecular mass of P2O4, and that's in grams per mole. Okay. Now I know that this line here, horizontal one, means divide. Remember, the vertical one means multiply. So I'm going to take my 0.65 moles, I'm going to multiply that by 141.94 times 0.65, and my answer is, I get 92, just erase this here, that's where I get my answer, 92.261 grams. So my answer will be 92.261 grams P2O5. We solved a mass moles problem. The next one, the next video, we'll do atoms and moles.